the language of the universe.
But I don't understand it.
Hello, everybody, and welcome back to another episode of the Math and Physics Podcast. I'm your host, Parker.
And I'm Ray, and we welcome you back to episode number 92, where this episode, ladies and gentlemen, is our closer for the year 2021.
Yep.
The last
episode
of this year.
of the entire year. So pretty much half of the episode, or maybe not half, but we're going to go over kind of the podcast over the year 2021. And then afterwards, we're going to do this like fan requested topic. Jennifer from Instagram, she wanted us to talk about the pyramids. And so we're going to do a little talk about the pyramids, what we know about the pyramids, like interesting properties, because actually we're going to get into it a little bit later.
The
but there's
pyramids
a lot
are
of
really
stuff
cool.
about the
Parker
pyramids,
and I
yeah.
have so many conversations and arguments on the origination of the pyramids and stuff like that. So, I think it's going to be a fun conversation. And also just one thing I did want to throw in there as well in this episode is just like a quick little recap. I mean, not that we know too much about these things anyways, but just like anything that we know about, just a recap of the year in physics, because there were some pretty famous things that happened this year. Muon G-2, James Webb that launched less than a week ago, some crazy things. So we can probably touch up on them a little bit here and there. And that's basically it.
100%.
So we can get into...
So, before we
Get into it.
get in, I guess this is getting into the podcast
Yeah,
itself.
right.
So we actually started off the year. Actually, on January 1st of 2021, we hit 3,000 followers on Spotify. And I remember this because, it was the new year and I checked and I was like, oh yeah, nice. We made it to 3,000.
Yeah, wasn't it
And
like
now-
on the first or something that we saw that
Yeah,
happening?
it was on the actual day.
Yeah.
And so now, right now we're recording this on the 26th of December, so we're probably going to be a little bit more by the time the new year comes. But we're sitting right now at 20.5 thousand followers. So
Wow.
what is that, like a 6 and 2/3 X? That's pretty cool.
I would
So-
invest into that stock. I would invest into that stock.
If we can do that again next year, that would be pretty insane.
That would be crazy. What, 6xing from here?
Yeah, that would be
6xing
insane.
from
We'd be
Yeah, it would
we'd
be
be at
quite
120,000 next year.
Would be quite
That'd
crazy.
be crazy.
Well, I mean, as always, thank you to everyone who continues to listen and follow us on Spotify. That
Yeah, 100.
is still our number one section of our listeners and viewers and everything. It's still on Spotify. And we've had a lot of commenters from YouTube actually mention that they were on Spotify first and then they found us on YouTube, or then they searched us up and then they saw
I
us
don't
on
know.
YouTube
I don't know
too.
if it's like finding us. We say
Okay,
it in every
finding was the
single
wrong word.
episode.
They saw that,
No,
hey, listen, they're
I
also
know.
doing a YouTube thing, so let's go check that out. And we have a lot of
Yeah.
comments being like, oh, I'm coming from Spotify. You guys are really cool. Never seen your faces before. And I think we've spoken about this before, how everyone keeps confusing us. So that's always funny to look at from our part too, because we're obviously not used to it. But that's that.
And so
Any,
in terms of downloads, back in January, like for the entire month of January, we got 16,000 downloads.
Oh.
And then like fast forward to like these past few months, we got like 40,000 downloads in like October, November. So yeah, just more people listening to the podcast. We're definitely happy about that, obviously. I'm really happy that people are just learning physics, because it's pretty much the best thing that you can learn if you had to like rank everything.
I mean,
Like-
obviously
like
we
how-
would say that.
But like if you think about it, like how can anything be placed higher than studying the universe? Like there's just no way. Physics is just
Physics in the
placed,
sense is the way of like questioning reality and really understanding the world
Yeah.
around us.
but like
So in a way,
physics
it is a very fundamental
obviously
science.
it's intertwined with math. So when I say physics, I mean math and physics at the same time. But yeah, this is pretty much the entire point of the podcast, is just to get people to study physics, because it's just the most crazy amazing thing ever.
Or not
So-
necessarily study physics, just to get people
No,
interested
yeah, I mean,
or re-intrigued into physics.
Yeah.
Because I still remember, again, these are just like comments that are just popping into my head right now that I'm remembering here and there. But I remember one individual who was on the older side of our viewers. I believe he was like 40 years old, and that was actually in the comment that I'm somewhere around 40, studied physics in undergrad, never cared about it after that. Recently found your podcast, and it re-intrigued my, my passion. And I'm like, what? We just got a 40-year-old to like physics again? Like, what? Like, like that's not common, especially like at a later stage of your life. Like, you're not always wanting to get into new things, but the fact that someone can still do that just means how much passion one can have for physics, right? Or just science. I should say science in general, because we probably have a lot of science lovers here that also watch our podcast that we probably are flaming as we're talking about physics.
No, I think it's always a funny joke to make fun of chemists and
Biologists.
biologists.
Yes, exactly.
It's so funny because it's so known that like physicists think that they're the best, but I think it's like I think even biologists have to acknowledge like, yeah, okay.
I don't know. Okay.
Physics
There's no the best,
is
though.
like,
Come on. There's no
you
the
know,
best. Like,
I'm
there
obviously
are
joking
ways.
to some degree.
Yeah, of course. I know you are too, but I'm saying like, in essence, like I think all of them have their own strengths. Like they all explain some parts of reality differently. So, it's all just cumulative science.
I do think, yeah, because at the end of the day, it's like there's physics, and then like applied physics is chemistry, applied chemistry is biology, and so it's all the same thing. Oh yeah, and then it's like applied biology is psychology, and it just keeps going. But it's like it's all connected in one stream. It's just wherever you pick to enter in that stream is just what you're gonna do. Unfortunately, there's just too many things to learn. You can't really do all of them. And actually, interestingly enough, like when we do history of physics episodes, it's like the people that were in the year 0 or even before that, every single one of them is like philosopher, mathematician, psychologist, like all of these. I don't really think psychology was a thing back in that time, but they were just all of the above. And that's because when you go into just studying in general back in those days, like it wasn't separated. Like you studied, when you studied physics, you studied astronomy at the same time, and you studied philosophy, you studied math at the same time, because they're all just together. Now it's just because we've discovered so much and things have become really complicated that one person can't really learn all of these topics anymore. If you're going to study something, you have to definitely specialize and just go even deeper, because if you do everything, then you can't really, like, you can just know things for yourself and be like, oh, I know a little bit of everything. But if you're trying to like find something at the cutting edge of the research in that field, you have to kind of dedicate your path in that direction.
That's what I said about, I think I've said this in another episode, but like as you continue, like there's just so much to know that it is literally impossible for one individual to know everything. And as I said, I think in a previous episode, I was like, I know less math this year than I did last year. And the meaning behind that statement is not to be taken explicitly, because basically what I'm trying to say is I know more math that I don't know about now than I did last year. You know what I mean? Like we're being like that's the idea of what I said, because what I'm saying is as you get more advanced, you start to see the amount of things that exist that you just are still so far from. Like when you learn one topic, you're like, oh my God, there are like 10 different subtopics with this, but I'm not doing it right now because that's advanced. And then you learn another topic and they're like, oh wait, there's like 20 more with this one too, but I'm not going to do that because that's advanced.
I think,
and then you keep going, and then there's just more subtopics that just keeps coming at you. Right.
Yeah, I think that was the case last year, but not this year for me. Because last year, going from single variable to multivariable
okay, because we didn't
calculus
do a
was
mathematical course this year, man. Of course.
I mean, I did, but
wait.
You know, it was more like I did linear algebra.
Oh
and then,
no, I'm
and then
talking
next
about
semester,
like a calculus based. I'm talking like a second year because what we did, or like the quote or the thing that I was thinking about, is because we were continuing the same class into second year. But I'm just saying, in general, when you're learning anything more advanced, you learn the more things that you don't know about, because there's so many things in this world, like quantum mechanics. When you learned, I'm assuming there are a lot of more things that you know this year than you did last year that you don't even understand. Right? There's so many
That's
more
not
things
that's
that you
not
don't.
actually true. Like, if you want to, like, specifically for quantum mechanics, you kind of just like, you just bite off what you can digest, and you don't really look at anything else. So it's like, I don't even know what's next, to be honest.
Okay, so maybe
I
quantum
don't
mechanics is different. Maybe quantum
it's
mechanics is different.
like, in terms of quantum mechanics, like, if I decide to keep going in quantum mechanics, like, once I get to that course, they'll be like, okay, here's how we make things more complicated, and then we just go on from there. But right now it's like, yeah, we studied, like, this is the same thing for every calculus course. In grade 12 you learn limits, derivatives, etc. And then in first year you learn limits, derivatives, etc. And then in second year, limits, derivatives. It's like, you just keep restarting, but you just make it harder. So you kind of know what's coming, but you don't really know how it's gonna come.
Yeah.
I don't really know where I was going with this sentence, but in terms of like quantum mechanics, you do like observables, spin, polarization, and then other things until you get to the hydrogen atom. And then in the continuation of that course, you just restart everything but make it more general. And then now, in the third iteration, I don't even know what's coming up. Like, I know the very first unit is like perturbation theory, but I don't even know how, like, that's gonna happen. So like,
Very
I don't know if they just restart everything that we've already seen and they just introduce new things, or if we just continue on. So yeah, we'll see.
That'll
We'll
be
see how that
interesting to see.
happens.
But point of this whole thing was basically the unknown is what intrigues us, and the more there is, the more unknown there is, the more you would want to know. Right? Very simple. And that's basically the act of all science.
So I think before
we get to the podcast.
No, no, this is the podcast.
I mean, I guess not. Sorry, before we get into the topic that we were going to talk about, comment of the week, or I don't know which camera is going to be working, but comment of the week. So this week we have a wonderful comment from Shikamaru Nara, and they say, "Hey, you guys suck." Nah, bro, you guys are awesome. Your episodes are so well designed that a little kid like me can understand flawlessly. You guys showed me this amazing world of maths and physics, which schools ignore. Thank you so much. And one thing to mention, I just saw. What? I didn't actually read this full comment before saying it out, because this is really cool. So he says, "Thank you so much, y'all. And one thing to mention, I just saw Rayhan's video in calculus. And wow, the energy of him is just amazing." Okay, so he's referring to something on my personal channel. Wow, I didn't know anyone would find that, but I guess so. So I had this weird thing on my whiteboards you might be able to see in the video, that I used to kind of stand on my whiteboards and just talk to myself and then just record it and put it on YouTube. And I used to love doing that. So I'm assuming that's what he's talking about. Well, thank you so much for that wonderful comment and somehow finding that video. But yeah, love to hear it.
If you want to be next week's comment of the week, just come onto this YouTube video here, subscribe, like, and leave a comment. Also, brand new feature on Spotify. You can now rate the podcast 5 stars. Exactly. So make sure to go and do that. Rate the podcast 5 stars. Why not?
Why not?
Yeah.
I think the feature was always on Apple, but I don't think anyone. It's not a big thing. So yeah, Spotify. Very excited that that's there.
Real quick, before we talk about the pyramids, I just wanted to say something. A couple days ago, the James Webb telescope officially launched into space.
That's
her. It was a successful launch. It's a $10 billion telescope, by the way. It's a 25-year project.
Oh, this thing was supposed to launch like every year for the last 5 years.
Yeah. No, yeah. But I watched like the super long, like 30-minute video on it, talking about like nice. all of all of the specifications of the
That's your
telescope and the mirrors, and it's absolutely like mind blowing. Like I don't know if everybody knows what it looks like, but basically there's like this wind solar shield, and then there's a telescope behind that because it needs to operate at a very low temperatures, and the inside, like the processor, the image processor, something like that, needs to operate at 7 degrees Kelvin. 7 degrees Kelvin.
That is cold.
And
That
so
is very cool.
they have this cooling system which actually works with acoustic waves, like literally sound waves. And so what it does is it sets up this standing wave where the high pressure and the low pressure areas are separated. And because, PV equals nRT, the pressure is proportional to temperature, what they do is they have like these pipes that can conduct heat. And so they have the high pressure area conducting its heat into the solar shield, and so it just like radiates out into space. And then they have another pipe in the low pressure area that conducts like the lack of heat into the processor. And so it just keeps cooling it that way. So that's pretty insane. Also, there are a bunch of layers in the solar shield, and I'm pretty sure, if I remember correctly, the thickest layer is 0.05 millimeters.
God damn.
The thickest one.
That is thick. That's crazy.
That's
Zero
like,
point
how
five
does
millimeters.
0.05?
0.5 millimeters. Oh
0.05, and that's the thickest one. I'm pretty sure the thinnest one is like something in the nanometers. Like I don't even know how it holds up. Who knows? Also, it's like this hexagonal, like this honeycomb shape for the mirrors, and they're all like modular. They can all like change their direction slightly, it's for adjustments. But also one crazy thing is that the telescope is not serviceable because it's being launched to the Lagrange point L2, which is 1,000,000 miles away from the
1.5
Earth.
million kilometers.
Kilometers. I said miles, but whatever. So it's going to be chilling there, and so we don't actually have the technology to like send people to go and fix it. So it's just not serviceable. And so what they did, if something were to happen to, like if something went wrong with the focus, the focal point of the mirror, they had to, they couldn't just send it out. They get back blurry photos, and they're like, oh well, they just leave it there. They actually made each of the modules that has like the mirror on it, they made them like they're able to change their concavity.
Yeah, that makes sense. I was actually just gonna ask if because that 100%. No, that has
So
to be
they can
something like
change they can change their direction, like where they point, and they can change their concavity. So they can just adjust the whole focal point action. And yeah, go ahead.
for a reference, because I don't know if many people even understand how large 1.5 million kilometers is. Hubble,
Yeah.
for example, is like 500, 600 kilometers from the surface
Well,
of
it's
the Earth.
orbiting the Earth.
It's orbiting the Earth. Yeah, it's like very, 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 very close, and that's our most sophisticated telescope out there. And this guy is now 1.5 million, basically around and looking at an unrestricted view of the sky, which is much far, far greater than anything we could have ever achieved or even hoped to have achieved with the Hubble, right? Also because of
Yeah.
atmospheric, a lot of things in there that it's obviously also being prevented.
But the reason why it's going all the way out there is because these Lagrange points are basically points in the, I guess, the solar system, but it's pretty relative to the Earth and the Sun and the Moon. I guess you do need to take that into consideration. But essentially there are these points where the forces kind of match up in a specific way that they can kind of just chill there, and over the orbit of the Earth around the Sun, it kind of, everything just works out so that the position relative to the Earth and the Sun stays constant over time. And so we can kind of just send it there and leave it there, and with a minimal amount of fuel, we can just kind of adjust its position, but it'll just naturally stay in the same relative position to the Earth and the Sun. So that's why we're sending it. But why are we sending it to L2 is actually because it's the furthest away from the Sun, and because the James Webb telescope is going to be looking at the most distant and earliest objects in the universe, you know, right after recombination, which I don't know if we've talked about recombination on the podcast before, but basically it's as soon as the universe went like transparent and you can actually see and photons could travel, it's going to be trying to capture those photons that have been traveling for 13.5 billion years. And the thing is, they're really spread out and they're really redshifted. And so apparently in this video that I watched, it's going to be like targeting these sources that emit, or not emit, it's going to be receiving 1 photon per second, which is not that much. Like, I think the comparison was that if you look at a star, like a bright star, your eye receives 1 million photons per second.
It's quite a lot
so
smaller.
If you can make that comparison there, it's going to be looking at very dim objects, very far away objects. And the thing is, if you remember, like electromagnetic radiation is like the energy is proportional or inversely proportional to the wavelength. And so in order to capture these really low energy photons, or relatively low energy photons, you need to have a very low amount of thermal energy in the receiver. That's why it has to be far away from the sun. That's why there needs to be like a sun shield in order to block out all this thermal energy, and also this like active cooler to keep everything cold.
Also because it's not directly on, you know, being cast by the Earth. That's why it also has to have significant protection.
Yeah, exactly. L2 is placed behind the Earth relative to the Sun Earth system. So
it'll take 29 days to get there. So
oh, you know what we totally forgot to do? We forgot to put the links to the things in last episode. You remember we shouted out some videos and stuff? We totally forgot to put the links.
We're so bad, man.
Because I was about to say, I'll put the link to the video in the description, and that
reminded me of it. We forget every time.
Yeah, we're so bad.
Even the professor said don't forget.
I know. You know what? I'm actually going to put a reminder in my phone right now to do that. And we'll put the links up on the last episode, too.
Oh, my. I just remember that, too. Man, that's
terrible. Yeah,
no,
that's hilarious.
Well, anyway, so yeah.
That's enough about the James Webb, I guess. Yeah.
James Webb is really cool, man. Like, I mean, the main goal, the main objective for this telescope is mainly just to look at the, as you were saying, like those OG stars. Let me say that.
Yeah.
The OG galaxies, you know, like those moments right after the Big Bang is really what it's trying to look at. And we can, I mean, hypothetically, we can really understand a lot more of the universe's starting point with this telescope. Because even though the Big Bang is a widely accepted theory, it's still just that. It's still just a theory, right? So, like, there's still it's not the Big Bang law. It's not the law of the Big Bang or something like that, right? So it's still being theorized. It's still being updated. Like, what are the specifics here and there? And this can just give
which is at the same time, it is kind of a guess, you know. The thing is, we'll never be able to confirm 100%.
I mean, yeah, obviously, because we weren't there.
I know. That's the fun part, though. It's like we have this evidence. Like, we have the CMB that we can look at. We can send really expensive telescopes to go look at it. And it's like, okay, the fact that we see the cosmic microwave background radiation, it has these properties and it looks like this, and we have a certain method to date things. We can make conclusions where it's like, this is a possible way that it could have happened, that now, billions of years later, we see these consequences. At the end of the day, you know, the universe could have been made up last Thursday. That was a funny thing that we talked about.
Last Thursday.
That was a funny thing we talked about.
That. So, quick update before we get into the pyramids. Just quick little run through I do want to do. for some big events this year. So in 2021, especially in physics, we had two major breakthroughs in the world of physics, and those are two specific experiments: the muon G-2 experiment, and then I don't know if this experiment has a formal name, but a theoretical time crystal. So the muon G-2, we actually had a really cool episode on that with Don Lincoln from Fermilab, the guy who literally runs the laboratory. So definitely go check that episode out. He actually talks intensively about the muon G-2 experiment itself, what it means, why it's important, and why it basically shatters what we understand. But quick rundown I'm going to give you guys. So the idea is that all these particles, these fundamental particles, have some idea of spin, of quantum mechanical spin that we understand. We've spoken about multiple times on the podcast. And when you put an external magnetic field on these particles, they basically start to wobble around, or they basically start to wobble in this thing, and the amount of wobble, or the magnetic wobble, is referred to as the G factor. And
it's actually interesting.
Yeah.
In one of my problem sets, it was like an extra problem that wasn't graded, but I did it. And actually, what we did is,
of course, you did.
we calculated what happens if you put like a particle that has a certain spin in a constant magnetic field that points in one single direction. And so I actually solved myself and saw that like the expectation value for the components of the spin, like the one that's in the direction of the magnetic field doesn't change, but the ones that are perpendicular to the magnetic field actually precess at a rate that is directly related to the strength of the magnetic field. And so the stronger the magnetic field is, the faster the spin precesses around the axis that the magnetic field points in.
Well, that's interesting to know. That's actually really cool that you actually did a
So that has to
problem
do
on
with
something
the wobble of the
yeah. That's actually really cool. So that's basically the inherent G factor, like an intrinsic magnetic compass almost. Because remember, they have their own compass, and you're putting an external compass. You're like, how much does it wobble? So that's the G factor. And the standard model of particle physics predicts G factors for all the particles, right? Like that's the whole point of the standard model. However, with a recent experiment a couple years back, they did it on the muon, and they found that the experimental results were about 3 sigma away from the standard model predictions. Now, sigma means standard deviations, and in like an experimentalist term, 5 standard deviations is significant enough to qualify for a new theory. So that's basically the idea.
5 is a lot, though.
5, yeah. So 5 standard deviations is enough to almost like solidify that a new theory is required or something is being misunderstood. So that was about 3, 2.7, 2.6. So it was something like that. And then they're like, oh my, let's just do it again. So then Fermilab comes up and does it again. And this happened this year, where they did it, and they got a result that was almost 4.8 sigma away from the standard model. So this is literally almost calling for a new theory, or we're just not understanding something about the original one. So again, we have one of two options. Either we're adding a particle, some other hidden particle is acting that we're not understanding, or we're not understanding the original already existing particles, which is a really cool theory. And I think on the episode itself with Don Lincoln, he was talking about how right now we can't really tell if that's the answer, but they are doing significant experimentation. And I think he said like next year or by the year after, we would know whether or not the model itself was incorrect. Because I believe he explained, he did something. He said something. Just go check out the episode. I would recommend everyone check it out.
I'm actually enticed to go and listen to it myself because I don't remember.
It's really cool.
I don't remember the whole conversation.
I guess I can say this, but we also have multiple clips on just the muon G-2 part. So if you just want to check out that, you can also just go on our YouTube and check that out. He has a very, very, very well. I mean, obviously, he's also a YouTube teacher. Like he teaches on YouTube as well. So like he's really, really good in terms of explanation. So definitely go check it out. So that's number one. Number two, real quick.
I don't think we have that much time, actually.
I don't even know
to,
enough
like,
about
go
this. I don't
into
even know
depth.
enough about.
Okay,
I maybe have
yeah.
2 sentences on this.
So just
and these are
mention it,
time
yeah.
crystals. So time crystals, I would recommend you searching them up yourself because I do not know enough about them. I just know that it was a significant discovery that happened this very year. And basically, the whole thing with time crystals is that a regular crystal is arranged in a certain way in space. And that arrangement does not change over the course of time. A time crystal is one where the arrangement of the crystal is set in space-time. So it can actually continuously move throughout what we perceive as our temporal dimension.
Damn.
So it's really advanced. Again, I would recommend you search it up yourself. The time crystal, really cool discovery made this very year. And it actually it breaks like time translational symmetry. So it was like okay, this is a big thing. And it was just some significant understanding of basic perpetual motions, because that, if you think about it, like time crystals are basically perpetual motion machines, because again they can like move from these things without taking any energy away because they're moving through time. So it's really cool. Again,
Wow.
if that explanation wasn't good enough, just search it up yourself because you'll probably get a better one. But definitely worth searching up. All right, let's get into it.
So now, a little bit of pyramid talk. Now here's the thing. Pyramids, there's a lot of unknowns. But let's talk about some of the things that we do know. Well, we know, I think this is the best thing that there is to know, and we know that they are there, which means that they were made at some point. That is undeniable, right? And that's one of the things that makes it so interesting, is that we have theories, you know, how were they built? We have theories, but we actually don't know for sure how they were made. Now, let me present to you some facts, okay? And I will make you have your own conclusions, okay? Just here's a little disclaimer. I am a big fan of believing that aliens built the pyramids. Here's the thing. The reason why I'm a big fan of this is because it's just fun. You know, it's fun to be like, oh yeah, the aliens made it. And the reason why I can, you know, say, a lot of people be like, oh, you believe in aliens built it. It's like, people think it's stupid, but it's like, yeah, well, you don't know how humans did it either. So, you know, your guess is as good as mine. Anyways, here's some cool stuff about the pyramids. 2.3 million blocks were used in the Great Pyramid, right? 2.3 million blocks.
Khufu's. That's Khufu's, right? Like, do you know the names?
Yeah.
Because I know there's Khufu.
I mean, they're
there's
called
Cheops, and there's someone else.
They have different names in like
Because
different
they were all
languages.
after pharaohs, right? Basically,
Yeah.
quick rundown of the pyramids. They were basically built because these pharaohs who own like everything were like, yo, I want a really cool tomb. So let's just make the most. Wait, why was it a pyramid shape though? Isn't there like a reason? Isn't there like
I don't know about the shape.
Know.
I think it was just the thing, you know. It's like the power, you know. The shape is
But like,
powerful.
why was it like?
I don't know.
Like they could have made just like a block.
That would be way harder though to
You're
build.
probably right.
That would be way harder to build.
Yeah, no, you're probably right. Pyramids are probably the easiest thing to make. Yeah, you're probably right.
Yeah,
You're probably right. You're probably right. Yeah.
So now here's something that's pretty, to me, is incredible. I can't believe it. So there were like 3 types of stones that were used to build the pyramid. Now, one of the types was granite. And the granite stones were actually transported 900 kilometers away from the site of construction of the pyramids. Now, get this. You might be asking, like, how do they know that? Well, there are no, like, granite deposits or whatever you call them, like spots where you get the granite from. And the closest, like, place that they could have gotten the granite from was 900 kilometers away. So, like, undoubtedly, that's where they went, because why would they go further away to get the, you know, anyways. The point is, these granite stones were used in the king's chamber, right? These pristine stones were used in the king's chamber. Now get this. These stones weighed between 25 and 80 tons each. Now, two things that should be blowing your mind. They carried stones that were 25 to 80 tons 900 kilometers away with no cars, no like mechanical technology, right? Like I'm pretty sure people say that it was either like boats.
I'm
to
gonna
put it
explain
in
to
the
you how
Nile
they did that.
River.
I'm gonna explain to you how they did
Hold
that
on,
in a
hold
second.
on. Or it was like, you know, they put the logs and they just pushed them against the logs, which I can't believe that. But anyway.
So yeah, there is an answer.
Wait,
to that.
wait.
Okay, continue.
The second thing though. That's the
Yeah.
first thing.
Okay.
900 kilometers away. Big granite stones. Here's the thing. The king's chamber is 45 meters above the base of the pyramid. 45 meters up, which means that somehow they had some technique that could literally haul. Now, I should have done this now that I think about it. I should have calculated the amount of gravitational potential energy that it takes
That would be
to
a very
actually
easy
lift.
calculation.
No, it would be a very easy calculation, but I'm saying I didn't do it. But that the sheer amount of energy to just haul those stones 45 meters above the base is just so crazy.
Okay.
So insane.
So let me try and answer them with the best of my knowledge and what I could find. So the first one has actually an answer, has a very famous answer that we actually have hieroglyphs of outside a lot of these pyramids and outside a lot of these, not the pyramids, sorry, outside a lot of these tombstones. So how did they haul these huge cinder blocks all of these hundreds of kilometers away? Because it was basically like there was sand. Like how are you gonna take them out? Like, you know, how are you gonna carry them? Here's the genius of the Egyptians. These guys knew physics. So what they did was they put these blocks on these sleds and they would pull them through the sand. But now you must be wondering, that's still crazy heavy. Like, that's not any lighter than just pushing the block itself. However, what they would do, and this you can actually see on a hieroglyphic image that they painted outside one famous tomb, where there is an individual that is constantly pouring something into the sand on this hieroglyph. You see this in like just pouring. You see these two individuals on either side pouring this thing into the sand before, like in front of the sled. That's water, straight up. So water, interestingly enough, significantly decreases the kinetic friction when on sand. So basically what the water did was it kind of lumped it up in a way where the friction drastically decreased to the point where if you have 100 or 1,000 people pulling this huge block, it's significantly easier. So this is actually true fact because, again, I mean, it was hieroglyphs. So, I mean, we're assuming that this was how it's done. And there were huge things that they would carry with like hundreds of people carrying it. And like these individuals on the front row just pouring water, just pouring right amount of water. You can't just dump water in there. There's a certain amount of water you need to not make it too clumpy, but to make it just enough so that the friction is greatly reduced. And obviously, they were smart guys. I mean, they built a goddamn pyramid, so they knew how much water to put. So that answer actually does exist. Now, how they got it to the top, no one really knows. Like, there are a lot of theories. Like, the most famous theory is the ramp theory. But there's no real answer to, like, how they really got it up there. Because, I mean, at the end of the day, no one really knows. So
what like actually happened is that just, you know, the aliens just had, you know, their anti-gravity pockets
of
that they
course.
would just put the blocks up. And then obviously the pharaohs were like, yo, if I just say that I built this, people are going to think that I'm like the most powerful leader of all time. Obviously, why would you not take credit
100%,
for
yeah.
these unbelievable feats?
Yeah,
right?
these aliens, I believe you. Like, the aliens came from another world to our world, built something for us, and then left.
I mean, it's the same universe, but you know.
Why? Why would you ever do that? Why would you build something in another person's planet and then just leave?
Here, because you want to let them know that you exist, and here's why, okay?
Anyway, okay.
And how do we know? How do we know that they exist? Well, here's one thing that is universal, right? Around the universe, the speed of light is the same
Okay, the speed of light thing is
around.
crazy. Are you gonna pull it up right now? Are you gonna pull that
Yeah.
fact up?
Here's
That's
the
a
thing.
crazy fact.
There are a lot of reasons why this is just a coincidence.
Okay, this is
and
this
I will
is crazy.
I will
This
I
I will
will
admit.
name them.
This I will admit is absolutely mind-boggling to me too. Like,
Yeah.
I just can't wrap my
So-
head around this.
So the speed of light is constant in the whole universe, and if an intelligent civilization were to pop up somewhere, what's the one sign that, like, okay, you are officially a super intelligent civilization? Well, you figure out the speed of light, because no matter where you are in the universe, you'll come up with the same number. Even, it might be in a different base, a different, like, counting system, different units, but it'll be the same quantity. Now, the speed of light is 299,792,458 meters per second. And the latitude of the Great Pyramid of Giza is 299,792,458 degrees, which is the exact same thing as the exact same number as the speed of light. So if you were to think about it, aliens are like, we're going to make this crazy building that there's no way that the humans would be able to build themselves, and we're going to put it at the exact coordinate of the speed of light, so that when they figure out the speed of light and they make that connection, they'll be like, oh, there you go. That's why they put it there. But now here's the thing. Here's a lot of reasons why this is not connected in any way. Number one, how did they know we were counting in base 10? And also, how did they know that our units were in meters and in seconds? Because why would they have the same measure for time and the same measure for distance? Also, how did they know that we would calculate the latitude in degrees when you can literally separate angles into any measure you want to? So the fact that they got all those things right at the same time, and they guessed that we would have all these things, kind of makes you think, like, wow, maybe there is no real correlation between the two values. But it's insane that they line up so well.
It is. Like, I don't even know where to begin. Like, that is actually that is really crazy. That's one thing that, damn, I don't even know where to begin from on that factoid. Like, that's just mind-boggling to me.
There's a lot
Exact point.
There's also a lot of, like, speculative things, like, if you calculate, like, if you draw a circle between the peak, like, that intersects the peak and the base corner, it has, like, the same ratio between, like, the Earth and, like, something else.
Isn't there also, like the peaks line up with some special stars?
Yeah, they do.
Something like that too, right?
They do, yeah.
Yeah. They line
I'm
up
pretty
with
sure
some
that was
very-
on purpose, though. That was for sure on purpose.
I think that was on purpose. Like, they'd actually line up. Oh my god, we should really know this talking about the pyramids. But it's like 3 very famous stars that they line up
No,
with.
but I guess the thing about talking about the pyramids is that we're not really historians or geologists. It's just
Whatsoever.
cool. It's just cool to
Whatsoever.
talk about. And it has to do with physics, because, speed of light, and also, like, civil engineering is
Yeah, like, how did they
physics, so-
get these blocks up there, Like, also,
Exactly.
interestingly enough, these pyramids, and this is actually not known to a lot of people, these pyramids were covered in marble, granite, and gold at one point. Like,
Yeah.
the tops of all these pyramids were covered
Yeah.
in gold. And it was again, I can't remember his name for the life of me, but it was some king at that time that came into Egypt and basically, like, literally rode all of the pyramids, right? Like, if you look at the pyramids now, you can tell that they've kind of been chipped off. Like, someone like, if you actually
Oh,
again,
Ray, you didn't even mention that you were there.
I actually was there. Yes,
You
interesting
were-
fact, thank you. So
you
actually, me
went.
and my family, I went to Egypt a couple years back, and we saw the pyramids and the Sphinx and everything, and we had this tour guide basically telling us this whole story. And he's so knowledgeable, man. These tour guides are basically better than Google. I'm not even joking. Like, they're crazy. Anyways, so this guy's talking about how these pharaohs were literally so rich that they could do whatever they wanted with all this. And because the biggest advantage that these people had over anything, and this is going to sound very bad in this day and age, but, like, the biggest advantage, fact or not, was slaves. Like, clear cut, the fact that they didn't care how many people died along the way was the reason that they could do this. Or at least it was what accelerated them doing it in the first place, right? So pyramids, super cool. I don't know if we gave you a lot of information that you probably don't already know, but at least we were really interested in it, and someone asked us to talk about it, so here we are.
Now, unfortunately, we do have like time obligations right now, and so we can't keep this episode going.
But do we even
we
have?
would talk
I
longer
think,
about it.
I think we're good. I think if we could get any sort of historian from
that
U
would be
of T
cool.
or something
That would be really cool.
to talk about the pyramids,
Yeah,
that would be
really
mind blowing.
cool.
Let us know in the description or in the comments or whatever if you want us to do something like that. That would be really cool. Actually, we might just do. Yeah, I mean that does sound really cool. So we might just do
it sounds really cool. Yeah.
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 So,
anyways, I hope you guys enjoyed this Christmas special episode. Where
holiday
we just
special.
talk
Let's say
about
holiday special. Yeah.
The holiday special episode where we talk about just random stuff.
Yeah, basically.
We
spoke about basically the
was
recap
planned,
of
but-
the year and then some cool fan stuff. Like basically that's what we did. We kind of spoke about the year. We spoke about some year in physics, year of our podcast. As you guys all know, if you checked out our Instagram, we had a really cool Wrapped on Spotify this year. You know, we went to top 11 on the chart, so that was really cool. Anyways, I think that was basically this episode. Everyone have a lovely rest of your year. Have a great
Make sure to follow the episode and rate the episode 5 stars on Spotify. This has been number 92. I am your host, Parker.
And I'm Ray, and we shall see you next year. Take care.